Hey, back. 14. These are all review questions, which makes them very important. So number 14, y equals 3x squared subtract 5 to the exponent 8. Can you take the derivative? I hope so. So it's the power rule. So 8 times 1 in front. Write down 3x squared subtract 5. Subtract 1 to the exponent, so it's 7. And then the hook. The derivative of 3x squared is 6x. And you don't have to simplify it at all. The derivative with the hook. 15. We have x squared. I'm right away going to write this as x cubed subtract 5 to the exponent 1/4. Let me show you. How would you take the derivative? It's the product rule. What is the product rule? That is the first times the derivative of the second. Remember, when you subtract 1, subtract 4 is negative 3/4. And then the hook, which is 3x squared, plus the second, x cubed subtract 5 to the quarter, times the derivative of the first, which is 2x. Done. I don't need that simplified. 16. T squared minus 1, t cubed plus 3. Take the derivative. What rule are you going to use? So to take the derivative here, you're going to use the quotient rule. What is the quotient rule? That is the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. Done. 17. Use the limit definition. So to find the derivative using a limit, we'd say as x approaches h, and then it would be x plus h squared minus x plus h minus parentheses x squared minus x all over h. Let me show you. So that's the limit as x approaches h. Plug in x plus h. Subtract the function all over h. Now the algebra to find the derivative. So I'm going to expand the numerator. I'm going to FOIL this out. So it's x squared. We have 2xh and h squared. We have negative h, negative x, negative h, negative x squared plus x. Now we get to do some simplifying. So if I simplify this, x squared and negative x squared, negative x and positive x, and then what's left over, I'm going to factor out an h. So if I factor out an h in front, I get 2x plus h minus 1. The h's finally divide out, and then plug in, did I say as x approaches, as h approaches 0, my bad, as h approaches 0. So now plug in 0 for h, and you have 2x subtract 1. That's the derivative. Double check, did you do it correctly? So the derivative would have been, 2x subtract 1. All right, number 18. In number 18, you have piecewise. The first piece is 2x squared minus x plus 1. That's when x is less than 1. X cubed plus 1. That's when x is greater than 1. And then there's a bunch of questions. So let's start it. F. What's f at 1? So is it the top piece or bottom piece where it's equal to 1? And it's the top one. So just plug 1 into the top and you get 2. 2. That's the answer. B. I should have my answer key ready here just to double check so I don't make a mistake. Part B. Can you find the limit as x approaches 1 from the left? So that's plugging 1 into the top. We just did that. The answer is 2. So the limit as x approaches 1 from the left, the answer again is 1. How about the limit as x approaches 1 from the right side. So from the right, plug in 1, and 1 cubed plus 1, that's 2. So f at 1 is 2. Again, oops, this answer is 2. So if 1 from the left, if you plug it in, you get 2. 1 from the right, you get 2. So are they approaching the same y value? Yes. Oh, take the derivative of f at x. So the derivative of f at x is just taking the derivative of each piece. So the top would be 4x, subtract 1. The bottom piece would be 3x squared. And then the question is, oh, does the derivative exist at 1? And so if I plug in positive 1, the derivative, top does equal bottom. The derivative does exist. So if you plug in 1 on the top and 1 on the bottom for the derivative, you get 3 for both. So here's the derivative. Plug 1 into the top, 1 into the bottom, you get the same answer. So the derivative exists and it's 3. 19. Is the function from problem 18 continuous? Why or why not? So the answer is this. The answer is yes. But why is it yes? What's a good reason to give for the reason yes? Let me say yes. And for calculus, what we're looking for is this. The limit as x approaches 1 from the left equals the limit as x approaches 1 from the right, which also... So the limit as x approaches 1 from the left equals the limit as x approaches 1 from the right is equal to f at 1. So the limit on the left, the limit on the right, and the value of the function all equal each other. That's continuity. Calculus version of continuity. It has to do with limits and the function value. They all equal the same value. It is continuous, and that's how you would show it. Number 20. Find equations for lines tangent to the graph of the function in problem 18 at x equals 1, 0, and 2. So if it's going to be tangent to that, so for 20, I said the wrong. 20 is the function in a differentiable everywhere. Why or why not? And the answer again is yes. So let me do that with differentiability. So why is the answer yes to number 20? And it's the same idea that the derivative, this time, not f at x, boop, there it is. So the derivative from the left is equal to the derivative from the right. So, and it's equal to the derivative at 1. So you can see from the left, from the right, and the actual value of the derivative, all of that equals, and that means yes, it's differentiable. 21. Still with that same question. And it says find equations for lines tangent. So if I want an equation of a line tangent, then I need to know the x value, the y value, and the slope. So for A, x is 1. That's the top piece. So plug in 1. Again, you get y is equal to 2. And the derivative, we just found the derivative at 1 on the left side. And we said the derivative there is 3. So we already did this work, 1, 2, and 3. So the equation is 3x minus 1 plus 2. There it is. That's the equation of the tangent line. At x equals, is it 0? Yep. So that's the top piece is less than 0. So if I plug in 0, I get y is 1. And then the derivative on the left, again, let me just remind myself what the derivative is. So the derivative of the top piece is 4x minus 1. If I plug in 0, the slope is negative 1. So take the derivative of the top piece, plug 0 in for x, and you get negative 1. So the equation is negative 1, x minus 0 plus 1. You could write it differently, but that is definitely the right answer. Part C, x equals 2. So that's the bottom piece when x equals 2. So in the bottom piece, 2 cubed is 8, plus 1 is 9. The slope, I need to know the derivative of the bottom piece, which is 3x squared. I'll go from there. And so plug 2 into the derivative, and you get 2 squared times 3. So the slope is 12. So it's y equals 12, x minus 2 plus 9. Oop. All right, number 22. Here we go. So we're integrating from 0 to 3, f of x dx, and it's equal to 5. We're integrating from 3 to 5, f of x dx, and it's equal to negative 2. We're integrating 0 to 3, g at x dx, and it's equal to negative 1. So there's a bunch of information I need to know, and then I'm going to answer a bunch of this. So let me just write them down. So from 0 to 3, if you add f at x plus g at x dx, what the answer is going to be. So for the first one, from 0 to 3 for f at x, it's 5. From 0 to 3 for g at x, it's negative 1. So it's just 5 and negative 1. Well, that's 4. So that's pretty simple. Part B. Oops. So when you go 3, that 3 can actually be in front of the integration. So for this one, what is it from 0 to 3 g at x? What's the answer? Negative 1. And just multiply it times 3. So that's why it's negative 3. For part C, integrate from 0 to 3 2 g at x minus 5 f at x. Just do a little bit of math. Like, it's not even that hard. So from 0 to 3, g at x here is negative 1. So it's 2 times negative 1. F at x from 0 to 3 is 5. So it's negative 5 times 5. So kind of put it all together. Negative 2, negative 25, right? 5 times 5 is 25. So 2 take away 25, right? So negative 2 take away 25. I think it's negative 27. It is. D. From 0 to 5, f at x. Well, from 0 to 3, it's 5. From 3 to 5, it's negative 2. So from 0 to 5, combine these together. 5 take away 2. And you get 3. E. Integrate from 5 to 0. Notice how they flippity-flipped it. So how do you handle it if it gets flippity-flipped? So we just answered this one. This answer in part D was positive 3. If you flippity-flip it, it's the same answer but opposite. So instead of positive 3, it's negative 3 times 2. So that's why it's negative 6. So it's the same, it's the opposite answer if you flip the bounds. So from 0 to 5, the answer was 3. So from 5 to 0, it's negative 3 times 2 is negative 6. Here, f, if you don't change the bounds from 3 to 3, it's 0. So if the bounds stay the same number, then the answer is 0. Because you're going from 3 to 3. You're not moving. So the answer is 0. There's no area under the curve. Let me show you my work. So there's A and B and C and D. and E and F. So there are your answers. You can press pause and figure that out. 2 more left. 23. In 23, you're given the derivative is sine squared x, and you're told that f at 0 equals 2, and to find f at 3. This is a calculator question. Even though it doesn't tell you, I'm telling you it's a calculator question. So in order to do this, this is a starting value question. So at 0, what's the starting value? 2. And then we add and we set up an integration. The integration goes from 0 to 3. And I'm integrating the derivative to know how much it increased or decreased from there. And now the question is, can you put that in your calculator? Sure you can. So it's 2 plus menu, calculus, integrate. And again, we're going from 0 to 3. And it's sine x and it's squared. So I'm going to write it this way. So sine x, and then I should have really put, here, let me try that again. Let's start with parentheses. A little tricky. So with parentheses, sine, so press the trig button, and then sine x, and then outside the parentheses, square it. Okay, that's what it means. Sine x, and you squared it. Now go Control Enter. Remember, the rule is 3 numbers to the right of the decimal, so 3.569. You don't have to round. And you have your answer. 3.569. All right, last question for your assignment, number 24. You're evaluating from 1 to 5, x squared. I'm going to already change it to x subtract 1 to the half. And then in number 24 it says, what do you do as a last resort? Give up. No. At last resort, you ask your math teacher and you just copy what he does. Nope, try again. It's U substitution. So let me show you it. So, U substitution, you're going to let U equal x minus 1. That means x, if you add 1, would be U plus 1. And then the derivative, dx, then is equal to du. The derivative of 1 is 0. All right, let's come back here. We're also going to change the bounds. So these bounds are in terms of x. We're going to change them into u. So we're going to go 5 take away 1 and 1 take away 1. So they change to 4 and 0. So now these bounds are in terms of u instead of x. Instead of x, we're going to put in u plus 1 squared. And then x subtract 1 is u, so it's u to the 1/2. And that's, this should have said dx. That means this is du. So now it's all in terms of u. So now what do I do here? The next step is I'm going to FOIL this. So if I FOIL this, it's u squared plus 2u plus 1 times u to the 1/2 du. The next step, I'm going to distribute, and I'm going to add the exponents. So if I go 2 plus 1/2, it's 2.5 or 5 over 2. If I go 1 plus 1/2, it's 1.5 or 3 over 2. And then 1 times that is just u to the 1/2. So now we're ready to do the calculus. So the rule is to add 1 and then divide, or the reciprocal. So 5 plus 2 makes it 7 over 2, and then the reciprocal. 3 plus 2 is 5 over 2, or the reciprocal. And then 1 plus 2 is 3 over 2, and again the reciprocal, instead of dividing. And then we're plugging in from 0 to 4. And now the last step. Just making sure that we're good, which we are. So it's 2/7, plug in 4. And you don't have to simplify that. This is 4 over 5. And again, it's 4 to the 5 over 2. And it's 4 to the 3 over 2. So just plug in 4 for you. Now, normally we would do this. We would subtract, and then you'd plug in 0. But you can tell if you plug in 0, 0, 0, don't assume it, but you can see that plugging in 0 gives you the answer 0. So I don't need that at the end, nor do I need the headache of rewriting it all if all it is subtracting 0. That is your answer, and you did your assignment. I am so proud of you. Mr. G Math, over and out, and until next time.